feel a little bit behind getting set up here. Okay, so we're going to talk about the combination of functions. This should be familiar to you, okay? There are 5 ways that we are going to combine functions. You probably did this last year, but we're going to take it a step further and identify the domain each time, okay? So first of all, it is important to understand that we cannot, it's important to understand that we cannot combine functions unless they have overlapping domains, okay? So if we have, they don't have to have the same domain, but at least a piece has to overlap. So the square root function has a domain of 0 to infinity, and a quadratic has a domain of all real numbers. Those at least overlap from 0 to infinity, so we can combine them, okay? However, if we had these 2 graphs have no domain that's in common, so we would not be able to combine them to be one function. Okay? We can only combine our functions where our domains overlap. And we're not going to worry about what the pictures look like. We're really just going to do the algebra, but then I am going to ask you to identify the domain. So we'll talk about the 4 basic ways first, and then the 5th way is something that you did get to do in your on the quiz, but not in the way we're going to do it today. So first of all, I want you to write down some notation, so when you see the function notation, you don't pin it. Okay. So if we want to add 2 functions together, that's fine, but this is the function notation for it, f plus g of x. That means take f of x and add it to g of x. I bet you can figure out what the next one's going to be and what the function notation is going to look like, right? We want the difference between 2 functions, f minus g of x. We also have the product where we can multiply 2 of them together. So fg of x is how it looks. And then for our quotient, the division is probably going to be the simplest to perform. However, we have to make sure that our denominator is not going to equal 0. So that's something we will have to consider when we look at the domain of our quotient, because we want to make sure we are not going to divide by 0. Go ahead and write down these 2 functions. What kind of functions are we working with? Linear. And what kind of domain does a linear function have? Yep. So this function is a line. It has domain of all real numbers. This function is a line. It has a domain of all real numbers. And since our domains overlap, really they have the same domain, but since our domains overlap, it is okay to go ahead and combine them. Okay? So I'm actually going to ask you to work together at your pod to find me the sum, the difference, the product, and the quotient. Okay, some of them you're going to be able to simplify a little bit. Okay, I'm going to give you a few minutes to do this together, and then we'll talk about the answers and what their domains would be. Okay? Add, subtract, multiply, divide those two. I love hearing you guys compare answers with each other. Keep doing that. There's no solving. Yeah. Okay, perfect. I'll mark that down. Thank you.
There's no 2x minus x. So what's it? Oh, I mean, yeah.
One more minute. Will that be enough time? Maybe a minute and a half.
For the
Are you getting some more answers over here? Okay, awfully quiet. Yeah, no, that's good. I've just never watched violin play concerts, so I just want to make sure you're doing that.
yeah.
I just boiled minus 2x squared minus 10 minus 5x. So if you combine the like terms,
It would be plus
and then negative 5x.
Oh yeah, it's negative.
For product.
So for the last 2x plus 5x, Oh, so you have two.
I know, it sounds complicated.
But I have.
Oh, yeah, we already said that.
You guys have something on your.
Glad you thought of that.
What's your product? So 2x times negative x would be negative 2x.
Oh, yeah.
Okay.
Hey, thank you, sorry.
What do you cancel out with GCS? So it's not the long division, like,
I mean,
you cancel out
I
F.
think that's a lot
I
of
don't
money
know
though.
if I tried it in pen, and then now I'm gonna do it wrong.
Yeah. I mean, it's just a simple.
Yeah, it will be. 2x.
All right, we're gonna go ahead and get going on this.
Oh, no, it's because it's.
So when we add two functions together, we really just have, whoops. We really just have a problem of combining like terms, right? So we should get x minus 3. What kind of an equation is that? Linear again. So our linear equation has a domain of, everybody, all real numbers. Please make sure you are notating all real numbers in interval notation. That will be important tomorrow and Wednesday. Wednesday's your test. We really only have one more section after this. Okay, it's this, and then we have a section on Monday, and then our test is Wednesday. Okay? All right, the difference. Oh, that's a subtraction sign. It kind of meshed with my head. Okay, the biggest thing here, and I know some people were talking about this, but that subtraction needs to get carried through the entire second function. So you should end up with 3x minus 7, because this is 2x minus a negative x, so that combines for a 3x. Okay? What kind of function? Linear. So a domain of all real numbers. Okay. All right, your product, please make sure that each of these functions gets put in a set of parentheses so that you can FOIL. Okay? FOIL is not my favorite word, but I know that's what you kind of attach to. So when we FOIL, you should get these 4 different terms to combine to negative 2x squared plus 9x minus 10. Okay? What kind of equation is that? Quadratic. And a quadratic has a domain of all real numbers. All right. Let's make it exciting. Our quotient. So f divided by g of x. I don't know why there's a parenthesis. There we go. Okay. All you have to do is take f, which one was f? 2x minus 5, and divide it by 2 minus x. Is there anything we can factor out of the numerator? Is there anything we can factor out of the denominator? If we can't factor anything out, there's nothing to simplify. If we could factor out a 2 from each, then we could cancel those 2's, but there's nothing to factor out, so we can't simplify. So this is what we have. Okay? Now remember, I said that our denominator cannot equal 0. We can't divide by 0. That doesn't work. Okay? Which x value would make our denominator 0? Okay. So our domain has to be everything except 2. So anything below 2 is fine, and anything above 2 is fine, but we cannot have 2 in our domain because it would make our denominator 0. Alright. So let's talk about the fifth way we can combine functions. Okay? The fifth way we can combine functions would be through composition. Okay? That problem on your quiz, f of 2, that's the composition of 2 functions. That was f composed with f of 2. Now, I don't know what notation you used in Algebra 2, but here are the 2 types of notation. I'm guessing you're fairly familiar with this notation, f of g of x, but then this circle thing right here, it also means composition. So this is f composed with g of x. I want you to write down both notations so that you know that they mean the same thing. So we are going to work on the composition. You've done that before, but something you probably did not talk about in your Algebra 2 classes would have been the domain of that composition. Okay? So when we think of a composition, we think about taking G and plugging it in for F. So the outputs of G become our inputs for F. Okay? So like on your quiz, you took f of 2 and you calculated it to be 5, right? Well, then that was your output that you then put in to function f again, okay? So this inside, the outputs of the inside become the inputs for the outside, okay? What I want to talk about is the domain, okay? So I'm just going to have you write it down for now, and we're going to have to talk about it a little bit because I understand that you're going to write this down and you're really not going to have a lot of direction. So just write it down so that I don't have to try to explain it while you're writing. Okay. And you don't have to draw this picture. We're just going to kind of talk about it. Okay. So what happens when we have a composition function? First of all, f and g have to have overlapping domains, right? That has to happen in order to be able to combine functions. Okay. But the x's we're going to be the most concerned about first are that go into the inside. Okay. So if we're talking about f composed with g, we're first worried about the domain of G because those are the x's that we are allowed to plug in first. Okay? Well, then those outputs then get plugged in to F. Okay? And then we get something else. All right? So what we're going to be worried about is the domain for g of x and how that compares to the domain of our result. Okay? Trying to think of the situation here. So, let's say, okay, from your 8 basic function chart, you have the reciprocal function, and it has a restricted domain, right? X cannot equal 0, right? Well, if we combined it with like a linear function, then the domain would change, okay? It is possible that over here we could get like some type of linear function, but if we had a restricted domain to begin with, we have to take that into consideration. So we are going to have to look at the overlap between our domain from the input and the domain from our result and see where those overlap, okay? The composition of functions can really change the equation type. Some equations have domains of all real numbers. Some equations have domains that are fairly restricted. So we're going to do our algebra, but then we're going to have to think about our inputs for the inside function and how that affects the result. Okay? Right now I'm kind of talking and you're like, I'm not really sure what you mean. So let's just do an example and then we can talk through it again. Okay? So go ahead and write down these two functions for me, f and g. X squared plus 4 minus 4. X squared minus 4. Reagan, what would be the domain of x squared minus 4? All real numbers. All right, now here's a time where our transformation of functions is going to help us answer a question without actually having to do a lot of work. So radical x minus 3. That's a square root shifted right 3. What's its domain? Yep. Okay, I'll draw it up here for you. We have a square root shifted right 3. So our domain's from 3 to infinity. We don't actually have to graph it. We can think about what that looks like to be able to answer the question. Okay? All right. Do these domains overlap? Yes, so we can combine them. So let's go ahead and calculate f composed with g. Okay? Now, if you're not a big fan of this notation, that's not a problem. I need you to understand what it means, but then I don't mind if you change it to f of g of x. Okay? That's not a problem. Okay? So what do? We take function g, and that becomes our input for f. If I had f of 2, I would take 2 and plug it in for x. If I had f of 100, I would take 100 and I would plug it in for x. So if we have f of radical x minus 3, we are going to take radical x minus 3 and plug it in wherever there's an x. So function f is x squared minus 4, but instead of x, we replace it with function g. Questions before we continue? Our function is x squared minus 4. So x squared minus 4. We replaced the x with function g. So now what happens to the radical and the square? They cancel. So we're left with x minus 3 minus 4, which is really x minus 7. Okay. All right. So when I ask you for the domain, some of us are going to get really excited and say, sweet, it's a linear function. It's all real numbers. Okay? But we have to be careful. Okay? Yes, I know that x minus 7 would have a domain of all real numbers. However, our input function was g. So this was our result. Our input function was radical x minus 3, and we determined that that has a domain from 3 to infinity. From the get-go, can I plug in numbers less than 3? No. So at the end, I'm still not going to be able to plug in numbers less than 3. So we need to look at where these two overlap. And that would be from 3 to infinity. So the domain for our composition is the overlap of the result and the input, which in this case occurs from 3 to infinity. Questions? Okay, on your gold sheet, there are 1, 2, 3, 4, 5, 6, 7, 8 problems tonight. Okay? I would say the first few are going to deal with the addition, subtraction, multiplication, division, and then the last few are going to deal with composition. Okay? I believe it will ask you to find the domain every time, so you need to do that practice. That is something that is new for us in pre-calculus. You've done the other operations back in Algebra 2, so that is probably something I'm going to expect you to do on the test. Okay? Tomorrow we have function aerobics, so dress comfortably. Like, ladies, I wouldn't wear a dress tomorrow. Okay? I mean, we're not going to really get that crazy, but you'll just be more comfortable. Okay? And we will have a quiz on the material from 1.5 to 1.8. Okay? So what we did today, what we did yesterday, the stuff with piecewise functions, and then all the stuff for 1.5. Okay? If any of the material you have questions about, please see me. I will tell you that tomorrow I'm not going to be in my room right away because it's the NHS informational meeting, which some of you may be attending anyway. Let me go ahead and start this.